Hi everyone, and welcome to this lesson on managing alarms. So this is an expansion on other concepts that we've been through so far in this course. So as usual, we're just going to jump straight in. What we're going to be going through in this lesson should highlight a method by which we can manage alarms, and it can be used for various other things as well. So let's just have a look at what's changed first off. So we've still got two pressure managers, but the interface has been extended. So now we're bringing in four structures, so data, our systems, we've seen these two before, and now we've got alarm group and alarm management. And then on top of that, we have some inputs for high alarm, low alarm, and low alarm, and then the alarm trigger and alarm release delays. These here are set up as usints, so they're just numerical values that are being pulled in, and these are set up as time. And then we have a alarm inhibit as well, which turns off the alarms. So if we go inside the pressure manager and have a look inside, we've seen these two networks here before. This third one's just been added to highlight how we would manage an alarm. So I check if the alarm is greater than 0. If it is, then I enable the management of that alarm, so checking against the trigger and release, and then I actually manage the alarm itself. So let's have a look at how structures play into this before we sort of go in and have a look at how these alarms are actually managed. So what I've got here is I've created a folder which has just my analog alarms in, structures in, and to this I've added the basic alarms and basic alarm status. So let's have a look at basic alarms. This is going to be holding my trigger and release values, so these would be filled in by SCADA or a HMI. And then there's a declaration here to the status structure as well, so another nested structure. And in here, I'm holding my condition to say the high condition is active, is true. And then I have my high alarm is active, and I also have a high is in use. So no matter where I am in my project, I can always access my global data, which is pressure. And let's turn this view off. And this is looking at typed DUT pressure. I can come into my pressure. In here I have my analog, which is DUT analog. And in my analog, I now have alarms. I can go into alarms, which is DUT basic analog basic alarms. Oops. And in there, I get to my status, which means from a global path, I can always access this status and have a look at whether a condition is active and whether a alarm is still active, or if an alarm is actually in use. Now, it seems like a bit of overkill, but it makes more sense when you look at how we actually assign alarms. So I have some more structures for alarm group and alarm management. So let's have a look at alarm management first. So the stuff that's in this structure is used for the management of alarms. So things like, has a new alarm been raised? The accept single, accept all, these would be driven by push buttons, and then reset only accepted alarms. And you get the idea that this is the interaction with the alarm system. And then here I have alarm group, and I have my alarm active, alarm accepted, and my alarm status, which we'll come into in a second. So this alarm active here, you can see that they're all arrays 2048 boolean long. So that means that because they're all the same length, if I index one, if I use the same indexer for all of them, I'm going to be indexing them all in the same place. And what I have on my pressure manager, if I go back to the main, You remember we touched on these alarm usint values here. They are going to be my index values. So if I have a 1 here, I'm going to be looking at element 1 of my alarm group arrays. So I'm going to be turning on element 1 of alarm accepted when I accept an alarm, and when an alarm becomes active, I'll be turning on element 1 if I were to put a 1 on the front of that interface. Now, there's a problem with putting hard-coded elements there. If I go back to my PLC program and I just quickly populate these, if I were to make a mistake somewhere else, like just imagine this pressure transducer number 2 was in a different place in the project, and I put a 1 on there, I now have two number 1 elements that are being referenced and indexed, and that would cause a problem because I can't have two systems looking at the same alarm value or trying to drive the same alarm value. What actually happens is you can't accept the alarm. The code fails because it's being driven from somewhere else as well. When you accept the alarm, it doesn't actually get accepted. So what I like to do here is have a global variable list, which is defined as a constant list, which means you're not allowed to write to it, but you can set a value in the declaration window. So if we open this, and I'll just stick it to the side. So what I have here is my group 1, and then element 1, element 2, element 3, and you can see that they are defaulted values to 1, 2, 3. So whatever their suffix is there is what their value is, and you can see that it's declared as a variable global constant, which means I'm not allowed to write to it. It won't get updated. In fact, I think the compiler throws an error if you try to write to a constant. And then all I do is I drag out my G1 1 into there, and 2 into there, and 3, and the same for 4. And then what I'd usually do is write a comment above saying, that this alarm is assigned to pressure 1, high, and then the same for 2, 3, 4, and you get the gist. This approach is necessary if you're doing this, because if I were to accidentally use the wrong alarm there, so now I've got 2 references to G1, I can still cross-reference, which I can't do with static variables. With constant declarations. If I was to hard code in that one like I did earlier, I wouldn't be able to go to browse and then cross-reference. So I can see that I've got 2 reads here, and I know I should never have 2 reads for the alarm constants. So it would take me to the place that's wrong, and I would update it, and everything would be fine again. So now that outlines the sort of basic approach to this, so we have a manager which is expecting numerical inputs, so it knows where it's supposed to be indexing, and then everything else is passed as structures. We saw in a previous lesson that if we're passing in-out, it's much more efficient than passing all of these alarms just as a standard in interface. So because they're in-out, they're by reference, and that really speeds up the execution time, as opposed to passing them in or creating copies of them via an input interface. So let's have a look how things are actually working in here. So what I've got here is a high alarm. So that is my index. If it's above 0, then it's in use. So I don't use 0 because 0 means it's not in use. There's no alarm configured. It's just a nice easy way of turning all this alarm management off just because I haven't assigned it a value. And then what happens is I do my interlock management. So this is looking at the high trigger, high release. We've seen this in previous lessons. And then down here I have my actual alarm manager. So this is pulling in my alarm index. You can see here index. It's looking at my condition, which in this case is being driven from my interlock manager. So this is writing directly to the local data for this. So hi alarm manager dot condition, which is this input here. It's not a warning, and then by reference again, or via in out, I pass the alarm group. So that's those 3 arrays that are 2048 booleans long, and also the alarm management, and that gets pulled into here. And then I do a check here as well to make sure the index isn't 0. If it is 0 or less than 0, then I immediately exit this function. Having that there as a belt and braces approach is just useful, because it's very easy to forget to put that initial check for 0. And then all I've got here is some code that checks whether the condition is active, and then checks whether it needs to be accepted or reset. So this is the actual management of the alarm. Okay, so let's go online, which I've just done, and have a look at this online, because it'll make a little bit more sense as to what's actually happening in here if we're online. So let's just make this a bit bigger. So in principle, what we're doing here is we're passing the index in so that this alarm manager knows where to index the arrays, and then we pass in the management system, which is things like the reset button, the accept button, so we can manipulate those bits. Now, what I haven't shown in this lesson here is how you then go and interface all this stuff with Codesys alarms management system, and I'm not going to do that because it varies so differently to other PLCs and other WinCC SCADA systems and stuff like that, like Siemens WinCC. It's not really beneficial for the structured side of this course. So with that being said, what's happening here on line 1 is, or network 1, is just the jump out if we haven't got an index set for this alarm, which you can see here we've got set to 1, which we set our high alarm index to 1, and then network 2 here. This is only allowing the reset to occur if we know the alarm has been accepted by an operator. So we're looking at alarm management, reset accepted, that's the push button. So when someone presses the reset accepted alarms, and then what we're doing is a little bit of indirect addressing here. So we're going into our alarm group, which is the group of 3 arrays. We're looking at alarm accepted, and then we're indirectly addressing via the index. So the index in this case is set to 1, so we're going to pull out the Boolean value from that array in index 1's position. In this case, it's false, so it hasn't been accepted, and that's because it's not an alarm. So we've not been able to accept it. So this reset function wouldn't work right now for this particular alarm. So if we were in a condition, alarm condition, what would happen then is we'd be turning on the alarm active for index 1, or whichever index we've passed to this function. The alarm active would go true, and which is the output to say that this particular manager has an active alarm. And then we get into the acceptance of alarms here. So this holds itself on, because as soon as we turn this alarm active on via its index, we also check here if the alarm active is on, which is what we've just turned on here, and we haven't been reset yet, then hold yourself on to keep yourself high, and then that allows us to perform a accept via this code down here. So when the accept all button is pressed here, at this point this would be false, which is the alarm accepted through its index. This would be false because we haven't accepted it yet, but this is an OR gate here, so as soon as the accept all button gets pressed, we then switch on or give a true value to the alarm accepted at our index point. That then holds itself on, and the alarm accepted output is brought on for indication outside of the block. At this point then, this would now be true, which is our alarm accepted, and if the reset button was pressed, we would then break this hold on contact here, which is holding the alarm active. And once that alarm active is broken, then we can only do that when the condition is false, because otherwise the condition would be holding itself on. Once that's broke there, the latch has been broken, none of this can be true, so the accept goes false and the actual alarm active state goes false. Now, it probably doesn't mean that much right now, or if at all, like how we're actually managing these alarms. The principle is that this block works with our structures. So we can pass in an array of any size via a structure, and using this index method, we can index that array from anywhere in our project, as long as we're passing those alarm structures via in-out through our sort of hierarchy. So you'll notice that when we go back to our PLC program, our alarms are on the interface of pressure 1 manager and also on the global alarm manager. So that's interconnecting. So we're passing information from the outside of our object through to a child that's inside the object via interfaces, rather than the child, which is this global alarm manager, accessing that information directly. That's something that you want to try to avoid. It actually causes issues when you start to put stuff in libraries, especially in Siemens. Siemens will start to sort of throw errors saying you can't put things in a library if it's got dependencies on stuff that isn't coming through an interface, because you can't guarantee that another project would have that requirement. So always pass stuff through interfaces. It makes no difference if you pass it through in-out. We've seen that the efficiency gains of using in-out really negate the problem of jumping straight out of a program to get something out of global data. Of course, it makes your interfaces bigger at the beginning, but it is worth it, because you know that if something is on your interface at the topmost level, so at this program level here, that is all of the information that could possibly ever be in anything deeper than this object here. You're not going to get anything more than what exists on here. I've seen an awful lot of projects where you'll have a very, very small interface on here, and then you'll go into the object and there's global data everywhere. And actually the amount of information that's in this function block is massive. And you can't see very easily what you can change without affecting this function block, because everything is not through the interface. So definitely stay in the habit of moving stuff through the interface. So yeah, hopefully that makes sense. Really, like I said, the whole crux of this is that by using a very large data set to manage our alarms, so those 2048 booleans, of which there are 3 arrays that are involved in this, although I've only actually shown you 2. By using those and passing them by reference, we can actually create a global referencing system that doesn't matter how deep we are into a nested structures. We're always able to just access those elements via reference and update them, read them, manage them. And the nice thing about it is it can be encompassed into things like this pressure manager. It could be put inside a pump manager or an entire system manager. A 2 pump with 2 pressures and 2 tanks either side of the pumps. All of that could be wrapped up into one big system with all of these alarm managers sat inside their respective managements for the pump, for the pressures, for the tanks. They all use exactly the same alarm manager, but we don't have to have that alarm management system placed anywhere else in our code with sort of references going to it everywhere and all that sort of stuff. It's very nice and simple. You know that the alarms that appear on the interface here are managed by this manager, and all you need to know is the numbers that you pass it, and the group and the alarm management need to be passed to it, because we can have more than one group as well. You could have 10 groups if you wanted. No matter how you could have as many as you want. You just need to break down how long you want these groups to be. So yeah, that's it. This is one of the lessons where you need to download it and have a look and have a play. It makes a lot more sense going through this alongside the video and alongside this lesson, and finding your feet for yourself. There's an awful lot of information I've just sort of chucked at you here. It's really best to go through it, pausing the video, making sure you understand what I've just said, and if you're still stuck, ask me questions. I will do my best to answer them, and yeah, keep the information up to date.